Here we go. We have a question, split a linked list alternatively. So you have given a singly linked list head and our task is to complete the function this that splits the given linked list into two smaller linked lists. The sublist should be made from alternating elements from the original list. And we have a note here that says the sublist should be in the order with respect to the original list, and you have to return, I think it's you have to return an array containing the both sub linked list. So in this case we have a linked list. So the first linked list contains this and this, means alternating elements. Then next linked list contains this and these elements. So we have to return an array. Next we have this example. So the first linked list contains 2, 8 and 6, and next contains 5 and 9. And we have to return the head itself. In this only one element is given and another linked list is empty. So let's try to build the approach. So let's say we have this example and this is our head node. So we have to return two separate linked lists. So let me first create it. This is called head1, the value is -1, and the second is -1, it is called as head2. Then current 1 is pointing to head1 initially, and same applies for current 2. Next we have this head. We need to add it here. So what I will do is I will add current 1 dot next is equal to new node of the current value. It is 5. So that's how we have to create it. We have 5. Next we have used this element. We just jump to the next head node. So in this case the head now points to 9 and this 9 is added here. So we have to check, is a head not null, because the linked list can be even size, can be odd size. So we have to make sure this head is not null, so we can add after this. So then head again jumps to next node, but while adding we need to jump current 1 to next node and same for current 2. Now current 1 and current 2 points to the last node itself. The head is not null, we have to add it here. So let's add it, and then head jumps and current 1 jumps. Is head not null? Yes, so we have to add it here. 6. Then head jumps and current 2 jumps. Is head not null? Yes, so we have to add it here. Then current 1 jumps and head jumps. Is head not null? No, head is null. So we have head 1 and head 2. We have two separate linked lists, but -1 is useless. So first we need to make an array of type data type node. In this we will add head1 dot next, which means head1 now points to this. This is our head and this is the linked list. On the next value, head2 moves to next, then head2 dot next. So head2 linked list is this. So that's about the overall algorithm. Let's try to code this. So first we have answer 1 and answer 2 containing -1, and current 1 points to answer 1, current 2 points to answer 2. While this condition holds, we need to first add the current value after the current 1, which points to the last node of answer 1. So after adding this, head jumps and current 1 jumps. it's time to add current to, it's time to add next to the current to. So we have to make sure if we had not null, then we have to apply the same thing, this, but for head current to, and the node is added in the linked list answer to. So same applies here. So that's about it, but we have to return in an array of data type node. So let's first create it. So that's how we create an array. If it's an integer, we have to write int, but in this case the data type is node, and we have to add dot next and dot next. So let's give it a try. In between, let's talk about time and space complexity. In this case, the time complexity is order of n and space complexity is order of n. Let me just quickly connect to the internet. So now let's give it a try. So the code is given in the description box. If you like this video, give it a thumbs up, subscribe to this channel, and we have successfully solved this question. So let's see the expected time and space complexity. We have made the expected complexities, and I hope you have learned something new. Thank you all for watching.